Just going through our last unit, which was embedded system design, okay? Embedded system design and development. So I'll quickly share my screen and show you guys the slides. अभी screen पे दिख क्या रहा है? Can you confirm once?
Yes, sir, the embedded system.
Okay, slides are showing up. Fine, thank you so much for confirming. So, embedded system design and development. So, this unit basically focused on, a lot of selection and mostly design frameworks. Okay, and best practices while designing embedded systems because the perspective is like suppose we have to design a system, gather the best stuff out there, okay, best stuff or best products available in market to design the system, okay, but it should never be done this way. It should rather be done rather than best, you should select suitable or required products, okay, or required products. So this mindset changes when you study design and development best practices. Okay. So to uh, to support my point, I'd like to give you an example. So last day, like mm, a couple of days back, I was reviewing a project. Okay, and in that project, there was a simple application. Ultrasonic sensor was connected to Arduino, okay, for some stupid application, okay. So I asked them simple question: why would you go for Arduino, okay, when there are like even cheaper than Arduino wale processor are available in the market? Why would you go for Arduino? So the answer was like, oh, we only know Arduino, that's why we selected it. So it should not be done. Or they said like, okay, the code is easy in Arduino, but that should not be the answer. Then. If you selected, you should be able to define it, or defend your selection properly. Okay. Another thing is, if cheaper than your desired processor options are available, then go for that. Okay. So let me admit. So if the cheaper options available, always go for that. Those are suitable. I mean, if the resource constraints of the application and device are matching, then go for that device rather than spending more money on the more advanced processor or advanced, controller. Because when you increase this cost here, the overall product cost also goes up, and that is not the ideal market scenario that we want to be there, right? So never do this mistake. You will fall into blunders while designing the system. So it will it is applicable for the any project that you do, like any electronic based project. If you have, you can definitely consider these set of rules. So yeah. So this unit focuses on changing the mindset. Until unless we don't see the design best practices and development best practices, we don't know how to go with that design. So it will change that. So basically, then we started to study about that basic design process, how it was in early times and how it has evolved with time and how it is currently. So that thing got started later. So basically, as I told you, there are 3 points when we consider designing a system are important, which is time to market, design cost, and quality. So admit somebody's in the lobby. So yeah, so all these 3 points. One is design cost. So we just talked about design cost, okay? And design cost is something that goes up where if you select the wrong components, okay? The price that cannot be defended, okay? Your price point should be defendable, okay? Your product should not cost way too much. That is all I want to say. And when will that happen? When you select the wrong components or wrong modules for your project, okay, or for your application. So that should not happen. So this explains that. And the in design process, this is extremely, these 3 points are extremely important that we studied in the last unit on, like time to market, quality, and design cost. So design flows. Now we then we got started with basic design flows, and the first thing we saw was waterfall model. Now another thing I noticed when I was reviewing projects of student, they still think that this model is gonna get them through, okay, but let me tell you reality, this never works, okay. This is only, I can say, theory based model, okay. In everybody's report I will I'm seeing waterfall model ka image, and they are like, okay, this is the flow of our development. बोला, नहीं ये काम ही नहीं करेगा ये, क्योंकि nowadays basically if you are to go with waterfall flow model, you need to know your system from scratch, like each and everything from the very early stage, okay. So this is not possible nowadays. Things are getting delivered in sprints, right? And waterfall model is no more applicable. So remember that. Requirement architecture, coding, and testing. So this basically basic flow of any software development, okay. And since embedded is software plus hardware, okay, so we need to know the basic flow so that the same can be implemented on the hardware part, okay, and then it will be done. So so then what is spiral model? So in spiral model we saw that instead of just having things like this, it is written in spiral. And why spiral? Because now suppose you are in feasibility or specification stage of the design. On every stage you will be basically doing testing, requirement, and design, all these three things simultaneously. So that's how the spiral model works, and it is more detailed. So this is more applicable than the waterfall model. So बहुत सारे स्टूडेंट्स के रिपोर्ट में मैंने यही देखा है, सॉरी नॉट ये देखा. So if you are actually not, I mean nobody is actually referring to such outdated things nowadays. So and even if you have this model in front of you, nobody also does all these things all the time. So never never stick to a particular model with respect to explanation, okay, when you are doing your project stuff, okay. Be specific, at the same time know what you have written and what you are doing. So this is what it is. Then hardware software combination देखा हमने, like how exactly it works, like हार्डवेयर का and सॉफ्टवेयर का independently development होएगा, and then there will be integration, okay. So this is the actual actual flow of embedded system designing. So requirement and specification, then architecturing, then hardware and software design, hardware. And then if we further expand hardware and software design ke blocks, then you will see again similar things happen in these systems, because these are the two system independent system in itself. So these two things happened independently already over there, and then came over here, and then the integration happened, and then the system has got designed. So then we got started with design patterns, where uh, these design patterns are, for you to understand how the systems are designed, like more and more complex systems, specifically. Okay, so state machine state machine are like, state machine, we articulate the machine basically on paper in the form of states, so that it is easy for us to design and code that machines. Okay, suppose the any embedded system for that matter mostly has, finite, valid state or legit state. So these states, suppose these are the state S1, F2, S2. Okay, so something like that, the state machine will look like. And this is a very small thing, of course, but state machines are designed for a huge systems with lot of input data and output data. So this is a state machine, and the coding is very simple. Becomes simple when the states are known like this. So this is for. I mean, I have not gone into details of state machine pattern, because this goes much deeper into, VLSI part of, designs. So that's why. So yeah, sorry. So this is the state machine pattern. This is mostly for the large machines. Okay, just remember that. Then we saw observer pattern. Then we had singleton pattern, and then command pattern. So ये तीनों, observer, singleton, and command pattern, it is related to the code that we write. Okay, as a code, I mean, the command pattern is like, we you know and if an object is written, then that will be encapsulated as a command. So it means that if you have to reverse of, or if you have to undo certain action, since the object is mentioned as a command, that can be repeated, okay, at any point in time, and the action takes place. So these are sort of, best practices that we went through. Then with respect to categories, we have some other best practices that we studied in the last unit. So it says basically, like as I mentioned, this unit mostly focuses on this, because it tries to develop your mindset, okay, your design mindset, to be specific. Because uh, normally, if you are to design a system, you would not think of it like, from designing perspective. Because uh, you know there is a difference in between a carpenter, okay, and an interior designer. Okay, and what is that difference? Okay, a carpenter will do his own stuff his own way, okay, without knowing the aesthetics of the tasks. But interior designer, or an maybe say an architect for that matter, would know how and like why this thing is done and how it should look like. So that is basic difference, and this is why you should basically study this unit, to have that mindset. Okay, so yeah, this is the basic, ideology behind this unit. And the last unit that is we're gonna start like in some time is basically some, advanced topics that are happening in embedded system nowadays, which we'll just discuss. Okay, so that is another, very short unit, and then we'll basically start with more engaging and assignment sort of stuff in with our, remaining time. So resource constraint awareness, the best practice of memory and storage management, and processor optimization. Definitely, I'm not explaining these terms now. So since the resource constraint means what? Already embedded systems are resource constrained. So management of memory storage and processor is very important. Okay, so these are a few of the tips that we have written under each category. So power consumption, so it says implement low power modes in hardware when system is idle. So this is very obvious, but it has to be thought of while coding, okay, your system. So then comes some real time considerations. So we have to prioritize the time critical task and task scheduling. So when it comes to real time, RTOS comes into the play. Okay. Then we saw modular and layered architecture. Now, what is modular architecture? So to give you basic idea, modular is like architecture that has been split into different modules. Okay. So suppose एक system है तुम्हारे पास. Okay. So in this system there will be LCD module, there will be a controller, maybe there are some sensors, and so this will be called sensor module, LCD module, controller module. So I mean the system is already modular, right? And if something goes wrong with any part of it, we can debug it and repair it easily. Okay, but if it was integrated all together, okay, just for an example, okay, then you would never be able to do it that easily. Then hardware abstraction layer says, we talked about this earlier. So it is basically, uh, I gave you an example wherein one remote was controlling, multiple electronic devices. So how does remote know that how each device is operating? So remote does not, remote need not know how the device is operating. Okay, so there is a, if this is one device, this is second, this is third. So these are the hardware abstraction layers on top of all the devices, which interprets the command, okay, and then converts it into proper format that is needed for device to run. So it's hardware abstraction layer is the information that only remote needs to know in order to interface correctly to the device and accept the command. So this is what these sort of things should be done. So was the lobby? Just a second. So such things should be done. Then safety tolerance we saw wherein watchdog timer, then error handling and logging is very important, and redundancy. So watchdog timer is something that will recover your system from hung state after detecting it. Okay, so that's what we need watchdog timer for. Then okay, these are self-explanatory. Testing and debugging, again, this is one category, and best practice are unit testing, simulation and emulation, and in-system debugging. So, simulation emulation tool also we have seen. Unit testing is like, hey, I just want to ask you, have you guys written any unit tests so far while doing, you must have done a project in your bachelor's. So, uh, have you written any unit cases in your software development journey so far? Unit tests? Anyone have idea?
No, sir.
Okay, okay, fine. So simulation and in-system debugging. So JTAG is the new word you might be hearing about. It's just there is an IEEE standard for JTAG. Okay, it is it is a sort of debugging interface that has been offered as a standard in order to make things easier. Okay, just remember that no need to go deeper into that yet. Okay, so mostly like these terms, okay, whatever the advanced terms you see in these, mostly they go deeper into VLSI and stuff like that also. So version control and documentation, of course, only one name comes to my name is Git when I hear version control. There are other tools as well. So, but most widely used is this. And I would like to tell you one thing. So डॉक्यूमेंटेशन, तो तुम लोग कोई भी प्रोजेक्ट बना रहे हो, ठीक है, फॉर एग्जांपल यू आर डूइंग अ प्रोजेक्ट, then then comes a part to document it. Okay, then comes a part to document it. There's a report always for documentation, how the system is designed, what were the selection criteria, what was the design mechanism, flow charts, and everything would be there in that. So why is that in place? Anything, any idea about it? Why is that a report in place? Why do you need that? Any guesses? Basically, even when you go in corporate further, like in future, so documentation plays very important role. Anything you implement, anything they will ask you to document. Okay, they'll have their own set of document mechanism, and they'll ask you to add it because the next person that comes to work on, the same project, or when you leave, okay, we are not available. Even if you are available, people need to refer to something. Like I simply go to documentation and do their own stuff. Okay, so in corporate there is a lot of importance that is being given to documentation, and that's why you know report generation and all is asked for you guys to do. Like when you're doing projects, they ask you to prepare a report, detailed report. So this is for that purpose. Okay, that report is there so that you are used to document the things that you do. Then from security point of view, they recommend secure boot and firmware updates, then encryption and authentication, design tools will just run through. There's Altium for electronic like circuit design, like PCB design में जो layout होती है वो सब layouts and all. On PCB अगर तुमने turn किया PCB को तो component side अगर देखी तो you might notice such tracks. So which tool is there to design such tracks? Altium, CAD, OrCAD, Autodesk, Eagle. Okay, so out of these four, I've used these two, and I found them extremely useful. Especially Altium is a very heavy tool. Okay, on system. I mean, very memory intensive, but uh, fantastic tool. So in simulation, we have studied this, and yeah, Proteus is the best of all. Okay, I have used multisim also, but trust me, you will not like this. You will never like this after using Proteus. Okay, so Proteus is that good. So yeah. Then from FPGA design like perspective, we have Xylin as a tool. So this goes more into a VLSI side of embedded systems. So Xylin again, it develops in VHDL. Okay, it's this Verilog hardware descriptional language. It is a different language for VLSI devices. And again, Intel Quartus is another tool for the same. Then micro controller. So माइक्रो कंट्रोलर एंड प्रोसेसर डेवलपमेंट टूल, इसमें हमने कील देखा है. ओके, एंड वाइल कील because again, best in class tools we have used. Okay, so Keel comes on the top because it has a very wide range of processor that it supports, and okay, it creates code for, I mean, it supports and debug and simulate code, so it does everything basically. But the other tools are maybe specifically for only compilation. Okay, they might only create the hex file, they may not show you the live, ports and all, but Keel does it all. MP lab is also good. Okay, MP lab is not bad, but not bad, I'm saying is Keel is the best. So then software development and आर्टॉस के टूल फ्री आर्टॉस हमने देखा था. Then these two are new artoses that you are seeing. Okay, and Git, of course. Communication and simulation, communication protocol का simulation, इसमें Wireshark पे तुमने काम किया है already, so these are similar tools. So considering testability of the system, of the system, there are some standard practices that are mentioned from testability of the system. So first is modular design. We already saw this, compound isolation and interfaces and test points we have to take out. Then in circuit design, we should be using JTAG for debugging, increased debugging thing, and it is also called boundary scan. Okay, it is also called boundary scan because once the device is ready and it's on field, still it JTAG allows us to debug things. That's why it is called boundary scan. Okay, then built-in self-test. So these mechanisms are mostly included in the booting only of the device. Okay, but make sure it has it. Then test hooks and debug interfaces, design traceability, and redundant components for safety, critical systems. This is the last point in this. Then debugging things we saw. UART, okay, it is a synchronous transceiver. Okay, this is UART is mostly a serial communication. Okay, basically the fancy name for serial communication in controller. Okay, very fancy name. Don't get scared by this name. And debug port is like custom debug output. It talks about dedicating a port for debug debugging maybe in the future. So it could be anything, it could be done via serial communication using UART. But if you are doing it, but then security, you know security gets hampered, and you have to work more on that. So in the next semester, when you're studying embedded security, you will find why these boards are vulnerable. They act as vulnerability to our system. Then real-time debugging. So RTOS definitely has certain things that offer real-time debugging, because most of the real-time applications are based on RTOS. So initially, when RTOS was there, if you go through history, so it was really basic thing. No debugging mechanisms were there, but later they were added because as and how the need of that thing was being faced, things were started to evolve, and they have added certain things to it, and still it is developing. But so far, the point I'm trying to make is that in when Atos was designed, it was never designed, or it was never meant to be very debug friendly operating system, maybe I would say. Hardware breakpoints and watch points, then power management, then power management where low power microcontrollers and microprocessors. So it says choose always low power microcontroller. So lecture start करने से पहले ही we discuss few things. So uh, in your selection criteria, one point should be power consumption of your processor. Okay, because mostly systems are battery operated. Okay, and if your power consumption is more throughout the system, okay, there is not gonna work. Okay, then low power states and integrated peripherals. So uh, so it says that we have to choose the processor that have integrated peripherals. Example, a AAT and digital, then ADC is basically an to digital converter, but we have some other peripherals. Okay, sometimes, okay, some applications are based out of RTC. Okay, RTC is a real time clock. RTC कैसे होता है? तो anyways, just a question for you guys. Do you guys know हम अपने लैपटॉप में या पीसी में क्लॉक चलते रहता है? हाउ डज दैट रियली वर्क इवन इफ वी पावर ऑफ? यू गाइस मस्ट बी नोइंग इट, राइट? एनी कैन एनीवन आंसर मी दिस? वो क्लॉक चलते कैसे रहता है? अगर तुमने कंप्यूटर, ठीक है, लैपटॉप में तो यू विल से it's fine, but PC में when you shut it down, okay, even if you remove the your pin, then how would you how will you defend your point? Like how is it maintained? How the time, every time you turn your system on, how does it show you correct time? Any idea? Anyone? किसी को नहीं पता कि टाइम कैसे कंटिन्यू चलते रहता है पीसीज में, लैपटॉप्स में? Nobody knows about it. Are you guys there in call? Yes, you are very much there. So something called RTC works. Okay, RTC is real time clock. Okay, and this real time clock is an IC basically. Okay, RTC is an IC. But okay, as long as you're giving power to that IC, it will retain the states. Okay, but once the power is lost, it's like a RAM. Okay, when the power is lost, the data won't be retained. So there is a cell in your computer. Okay, that cell keeps delivering the power to this RTC. Okay, now what this integrated peripheral point says is that your processor should have maximum number of integrated uh, peripherals, such as analog to digital converter. Then there comes RTC, then there comes timers, counters, everything is inbuilt, right? So this is just to reduce the power consumption, because whenever we need, we're just switching them on or off based on the state of registers in our controller. Okay, they are not consuming any extra power. Okay, whereas if we connect it externally, then we'll again need to give that different power supply. Okay, so dynamic voltage and frequency scaling is also best practice, and when it comes to power management. So dynamic voltage and frequency scaling, it is the term itself is self explanatory. So dynamic scaling is basically it's a technique where it states that operating voltage and clock frequency are dynamically adjusted. See, based on you know the workload and performance requirements. So depending on that, if we are able to work on this part, like we are dynamically changing the voltage and frequency, then again power consumption is going to be low and the system battery is going to last. Okay, since these systems are deployed on field and they're mostly battery operated, clock gating is to be done, and low power peripherals. So consider peripherals that are low in power consumption. Then power, efficient power supply design. So efficient power supply design में low power voltage regulator dropout regulator. So what is low power voltage regulator? So, and it says you low power low dropout regulators. It means that voltage regulator is something, if you're designing a power supply, if you ever designed a power supply, you would know that first phase will be to step down the voltage. Okay, if we are having 230-volt AC mains, okay, then our small systems won't be able to take it. Okay, so using transformer, we basically step it down. Okay, we use transformer. Okay, then we have rectifier circuits here, rectifier. Then we have filter circuits to filter the signal further. After this, what we have is voltage regulator. वोल्टेज रेगुलेटर इज बेसिकली 3 पिन का आईसी होता है, बस 3 पिन ही होते हैं उसमें. सो दैट आईसी बेसिकली रेगुलेट्स द वोल्टेज. इसमें एक इनपुट, आई मीन एक वीसीसी, एक ग्राउंड एंड एक आउटपुट वोल्टेज होता है. सो जो कि रेगुलेटेड कांस्टेंट वोल्टेज होगा. ठीक है, जो भी है. ठीक है. And so it says that use low power voltage regulator. Okay, because voltage regulator काम कर रहा है, लेकिन वो काम करने के लिए भी कुछ पावर लगे. So that power it is talking about. And software level power management, basic practices that should be following within your software in order to you know, have low power mode in place. So it suggests us to have sleep mode, idle mode. Then okay, wait, it is like that. Okay, these all are sleep modes. Okay, idle, sleep, deep sleep, or wake up triggers. Okay, these all are not independent point. This is a you can say the header point. Okay, and these all are sleep modes. So idle mode, sleep mode, deep sleep or power down mode, and wake up or trigger. So these are the possible sleep modes that any controller could have. So have a look at the data sheets that comes with a manufacturer, and then you can design your code accordingly. Okay, so until now you've been just designing your code considering our functionality. Okay, functionality. So we are going way beyond that now. Okay, हमें फंक्शनैलिटी तो मेक श्योर करनी ही है, लेकिन ऐसे भी मोमेंट्स होंगे मेरे कोड में जब आई कैन थिंक ऑफ पुटिंग माय कंट्रोलर टू स्लीप. ओके, सो यू हैव टू थिंक ऑफ दैट. मैं शेरी शेयर, आई हैड टू गो बैक टू लॉबी टू एडमिट समवन. So then optimized code for power efficiency. Also, there are few key points that I have noted down here. Go through it when I share PPT. And optimized communication protocols. So this point you will always notice in embedded security also. So basically, a general purpose computer is designed for all the kinds of tasks, right? General uh, tasks, if I talk about. So suppose These general purpose computers are there for general tasks. So the protocols, okay, that are available in general computers are also generalized, right? Not specifically designed. So basically, you don't need everything. Is the thumb rule that you will see. Okay, you don't need everything that system has to offer. You don't need everything. You just need a part of it. Maybe you just need the idea of it. So take only that. Okay, don't just take everything that system has to offer and overcomplicate your system ever. Okay, and in that also specifically it states that low power communication protocols you should have. Okay, then duty cycling. I'm so sorry. Then there are some power management tips available for these peripheral devices. Peripheral devices means keypad, LCD. If you are connecting any external RTC, any external counters, anything that is consuming power basically, and and which is in modular format. Okay. Then monitoring and profiling we saw. Okay. Then there are tools that are available for that. This power aware operating system. So anyways, again, RTOS comes into play. Then testing के types देखे हमने. Testing how we done static, how we do in embedded means mostly from security perspective, from testing perspective, from integration perspective. So from security perspective, we have static code analyzers in place. Okay, and the tools are Misra C compliance checker. So when it comes to such uh, Misra C compliance checker is the name of the tool, but also MISR Misra C and CERT C. Okay, these two are compliance standards. Okay, this first one focuses on security. Sorry, yes, first one focuses on safety and second one focuses on security. So both of these should be checked while designing an embedded system. So there are tools available. Okay, we are going to study in next sem CPP check as a tool. Okay, as a static code analyzer. It's tool what it does is without running your code, it analyzes your code like statically compiles and it shows you the error and stuff. So it's that. Then first testing is when you actually bombard your system with lot of inputs. Okay, lot of inputs, and you see how your system behaves in that scenario. Okay, that is first testing. And unit testing, of course, unit testing. Then there's integration testing, system testing, hardware in loop testing, there penetration testing, so on and so forth. So this is how your last unit was. I just thought of going through it because I thought we just went through it like way too fast the last time because your TA2 was on head and I had to finish that unit. So let's take a break for maybe 5 or 10 minutes, okay, and be back. We'll start with fifth unit then, okay. Guys, you there?
Yes, sir.
ओके, सो अभी हम ना पांचवा यूनिट स्टार्ट करने वाले हैं जिसमें बहुत सारे पॉइंट्स रहेंगे नए नए. विल टॉक अ लिटिल बिट अबाउट आईओटी, विल लिटिल बिट टॉक अबाउट आईओटी सिक्योरिटी. We will talk about machine learning in embedded systems. We'll talk about all such kind of things, like different things. I mean, relating to embedded systems which are happening nowadays to embedded systems. Okay, so it will include a lot of interaction. It will include a lot of support from you guys, because you you will have to do things mostly. Okay, here, like you will do your own research. You might be presenting sometimes. So next few lectures will be like that. Okay, so starting today, so I need that thing from you now. So basically, this particular unit that I'm going to start right now is, you could say, an extended version of the currently going unit, like unit 4, but with different systems. Okay, so I'll present on screen. So तुम सबको OSI मॉडल पता ही है, राइट? OSI रेफरेंस मॉडल in networking.
Yes, sir.
Okay, so can you name the layers? Can anyone name me the layers of OSI model?
So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer.
Right. So this is OSI model. Okay. So can you also tell me what all applications use this model? Any idea where it is used? Any rough idea? Anyone?
In web browsing, sir, like
This is what,
HTTP and HTTPS.
those are protocols, okay? And that protocol is an application layer protocol that you just told me, okay? So web browsing, so web browser, okay? Browser comes falls under application layer, okay? Then there are other layers also. I was asking like where it is used, as in like any specific application. But I guess let me explain you first. So this is OSI, is called OSI reference model, right? So why is this word reference in between? Because this is just a reference model, okay? It's practically not applicable, okay? There is something called TCP/IP model. Have you heard? You must be knowing the layers also, right? TCP/IP maybe, okay? The advanced version of OSI model. Hmm? Have you heard TCP/IP?
Yes, sir.
Yes, sir.
So this actually comes into play in actual real world networking, okay? Not OSI. OSI is a reference model, okay? TCP/IP is actual model. So So any idea what is IoT? What is IoT according to you guys?
Internet of Things.
Oh, thanks. Thanks for telling the full form. Actually, see, Internet of Things. So, जब तुम ये वर्ड सुनते हो तो तुम्हारे दिमाग में आता क्या है? That is what I'm asking. कि मतलब, okay, it's fine, Internet of Things, but what do you think of it? Like, what it is exactly?
So it refers to a network of interconnected physical devices.
Oriented physical devices, right? So, and why do we connect those devices together? But why to connect it? So IoT, uh, is evolved embedded system, right? IoT is evolved version of embedded systems. So, what are you seeing on my screen right now? Whiteboard, right?
Yes, sir.
Yeah. So, IoT is a evolved version of embedded systems. Okay, and IoT is an embedded system itself. So, IoT device. So embed systems क्या issues solve कर रहे हैं तुम्हारे? Any focused issue, okay, which requires electronic intervention, like or any electronic system that is having a microcontroller or a code in place is called embed system, which is working on a particular issue. Okay, so these issues were very limited earlier, right? These issues were limited, but now the scope increased. Okay, scope increased. These devices came online. Okay, these devices got connected to internet. Then automation increased. Okay, need of automation increased rather. Okay, and that increased need caused you know evolution of IoT. So basically, what happens is, suppose there is a home automation implemented, okay, a lot of things, or let's say there is this power grid system, okay. So it has this electronic meter, okay, electronic meter that is connected, okay, to your AC mains, and the power coming out of that electronic meter is getting distributed to all the electronic devices in your house. So what happens here? The thing is, Internet of Things, how I can call this device as IoT device, and why would I call it as an IoT device, is because it is exchanging the information to the base station. Okay, it is exchanging the readings, it is exchanging the data with the main device, okay, or the base station, back and forth. Okay, it is receiving the data, it is processing the data, okay, plus it is deployed on a site, okay, customer site, and then it is exchanging the data. So this device is basically doing a lot of things. Okay, it is first of all deployed, it is reading some data, it is monitoring the data, basically how much power is going out, how much power should I consider as one unit when transferred. So it is doing a lot of calculation. So it is a smart device, plus it's an embedded IoT device. Okay, so this is what I mean by evolved embedded system and an IoT device. Okay, so this is definitely one of the advanced topic is embedded systems. So let's study the basic architecture and stuff, okay, of IoT. So we basically have layered architecture here, like we have uh, and why I asked you OSI and why I asked you TCP/IP. It's basically because of this, because in IoT you have these layers too, okay, which is but slightly different, okay, similar but different, okay. Just saying it's same but different, so it's kind of that. So so is the whiteboard still visible?
Yes,
Yes,
sir.
sir.
Yes, sir.
Thank you guys. So as you know that IoT has wide range of applications also, right? So also the use of IoT is growing like on a very faster pace. So IoT is networking of physical objects, as you said, Prathamesh, right? So its uh, architecture is also has to be networked. I mean, in networking sense, it has to be explained in networking sense. That's why I asked you TCP/IP and OSI for the relevance standpoint. So basically, it starts from uh, the very bottom layer, which is sensing layer, which is called sensing layer. Okay, now these layers are different. Okay, you would find networking differently, and this is stacked differently. So this is nothing but the physical layer, because it has what physical objects, okay. What objects? Now it is embedded system. Can you think of what physical objects I'm talking about, considering the name of the layer? Please tell me. This is an embedded system. The layer is IoT device. The layer is called sensing layer. Is basically the physical layer because it has physical objects. I'm saying. So, what physical object I'm talking about here? Sensors, guys. Sensors, actuators. The layer itself is sensing layer name. Okay. So, of course, sensors and actuators. So, it's a physical layer. Okay, is the first layer of IoT architecture, okay, and it's responsible mostly for collecting data from different data sources. It the layer, this layer basically a physical layer. It relates to physical layers, and it includes a sensing mechanisms and output givers like sensors and actuators, okay, and they are placed in environment to gather information about it could be temperature, it could be humidity, it could be light, it could be sound, right? It could be light like LDR sensor, right? It could be sound sensor like a mic, or it could be displacement, it could be weight, it could be anything, right? Any physical parameter, okay. It could be wired or wireless communication protocol, right, that connects these devices together in the networking layer. So this is the first layer, okay, sensing layer. It's called sensing layer because it has sensing the physical objects put together, okay. Then next comes is network layer. Okay. Now, any suggestions on network layer? Anyone want to talk about network layer in basically a TCP/IP model or a OSI model? Any description you know about network layers?
So it handles routing, addressing, and delivery across multiple networks.
Yeah, perfect. Okay. If you think of networking, this is the perfect, definition of network layer. So it is basically a layer of, IoT. Now we are studying IoT architecture, right? So how do you relate it? So it's the networking layer of IoT architecture. Okay, and what is it responsible for? It is responsible for providing what network, communication and connectivity between devices in the IoT system. Okay, now we are specifically talking about devices in the IoT system. Okay, so basically, uh, it is basically there to establish a connection between our IoT devices, which are supposed to be interconnected. Okay, मैंने जैसे कि पावर ग्रिड का एग्जांपल लिया था मीटरिंग का, तो वो मीटर बेस स्टेशन से कनेक्टेड, सो बेस स्टेशन पे देयर शुड बी some device which is there to receive the information that is there, right? So it is that. Okay, so it definitely includes, protocols and technologies that enable devices to connect and communicate, you know with each other, while internet is of course there in place. So to talk about an example, we can, I would say, network, technologies that commonly are used in IoT are like, Wi-Fi, Bluetooth maybe. Okay, this is not writing, I'm not sure why. Okay, cool. Okay, so Wi-Fi, maybe Bluetooth, maybe Zigbee, like that. Okay, just to establish connectivity. Okay, could be not always. Okay, it could be a cellular network also, like 4G, nowadays 5G. Okay, additionally it could be like, it may include, gateways and routers. Okay, as you mentioned. So basically, mm, intermediary. Okay, it acts as an intermediary device. Okay, for in between like other devices or the products. Okay, you have in your system. So and when we talk about IoT, it's sometimes, okay, depending on application, it could also, I mean, the encryption features also could be implemented at this layer. Okay, considering the criticality of the IoT application in the picture. Okay, so next layer is, in our IoT architecture is data processing layer. So which layer you can relate to in OSI? Just reading this name. Which layer do you relate from OSI model to this layer? Any idea? Like a data processing layer, like where can you relate it?
Sir, maybe data link layer.
Data link, exactly. Okay. So it's data processing layer. The name is data processing layer means definitely it must be doing something with data, right? It's processing it. So it's it refers to mostly like software, and hardware components that are responsible for collecting, analyzing, and sort of interpreting the data from IoT devices. So that's right. So this layer is, mostly responsible for receiving raw data, okay, then process it and making it available for further analysis. Okay. तो तुमको data receive हुआ है, okay, in raw format. So this layer will receive the data in raw format. It will process the data. It will convert it into readable, or I will whatever is the intended format. Okay, convert it, and it gets the data ready for further analysis. Okay. Okay. So then what we are going to see is that this layer is like responsible for like we just saw, it's receiving the data, it's processing and making it available for further analysis. Okay. So just give me a second. मैं दो पहले just करेंगे. Give me a second. Sorry for that. So where were we? Yeah, we were at this data processing layer, right? So the data processing layer, it also includes a variety of technology and tools, like data management system. It could be analytical platform, or it could be ML related, ML algorithm maybe. Okay. Also, these tools are used to extract meaningful insights. Okay. It could be also used for, I mean, everything related to data, right? It could be used to extract the meaningful insights from the data and make decisions, okay, that are based on data. Okay, for example, like say technology used in data processing layer is like uh, data lake, which is centralized repository to storing raw data from IoT devices like that. Okay, so it is like variety of things. Okay, it is like variety of things. It's variety of things related to data. Okay, मैंने एक word बोल दिया ना, data processing. Okay, it means everything that comes to your head with respect to data processing lies under this layer only. Okay, no other layer. So it could be any advanced algorithm, like ML algorithms maybe, or for analyzing the data, to be specific. So this is our data processing layer in IoT device. Okay. Then the very obvious, which layer will come in the top, like this is the final layer now. What layer will it be? Can anyone tell me? The only layer that is left now, can anyone tell me? We talked about physical layer, network layer, data link layer, okay, and now what is left is application layer.
Trans.
So, what you were saying transport?
Yes, sir.
No. So ये actually क्या है ना, this is more like TCP IP, like because मैंने starting में ही clear किया, right, कि TCP IP is what actually we use and not the OSI, okay. So it it is an application layer that is left now. We talked about physical network and data wali layer, now application layer, okay. So this this is basically, smart, application and, management sort of thing we have here. Like, if you talk about in terms of general purpose computing, then it comes out to be a web browser that Ramesh pointed out earlier. So the application layer of IoT in IoT architecture, okay, is the topmost layer, okay, that interacts directly to the end user. Definitely, right? It is, mostly responsible for what do we call as, providing, user friendly interface and, uh, you know functionalities that enable users to, access and control the IoT devices, okay. So it's it's basically, it could be a UI, okay, that is accessible to users. you know it provide, just to provide the user friendly interface and functionalities that you enable user to access the control the IoT device, for what, for controlling the IoT device. It could include your various, software and applications, like, it could be an mobile application, because we are talking about IoT devices here, right? It could be just mobile application. It could be any web portal that is talking to my IoT device, okay. Then it could also be like other interfaces that are designed to, interact with the, underlying IoT infrastructure, okay. It could also, include sort of, middleware software services or middleware services that allow, different IoT devices and systems to communicate and to mostly, share the information. So it's that, okay. The application layer also, it includes the analytics and, processing capabilities that allow data to be analyzed and transformed into meaningful insights, okay. So this can include, machine learning algorithms as well at this stage, okay. Also some data visualizations tools, okay, and also advanced analytical capabilities. So in data processing layer, we talked about data processing, okay. So data processing layer को मिलता है raw data, okay, raw data, and it processes it further, okay, for machine to understand the data and process it, okay. Application layer को भी जो data मिलता है ना, so it may not be possible for us to read it directly. So application layer का काम क्या होता है, to convert it and make it readable, okay, readable. So it could be again AI/ML based. It could be data visualization tools that are there in place. So it's like that. Okay. So that's about the IoT architecture. Okay, the rough IoT architecture, which includes basically sensing layer, then it had network layer, then it had data processing layer, and the final is application layer. Okay, so this is the IoT architecture. Okay, and if we talk about data flow, it would be back and forth. Okay, so IoT systems, if you talk about advantages, there are many, right? It has definitely made our life like really easy all these days. But if we talk about disadvantages, what they could be? Anyone? Can anyone talk about disadvantages of IoT devices? Consider the applications, na? Modern applications. Okay. Applications. So let's do one thing. Um, okay, we'll do that in next lecture. 17. 17 हो गए ना guys. So the thing I was talking about, मैं बोल रहा था कि advantage तो हम बहुत ज़्यादा list कर सकते हैं IoT devices के. So if I am to talk about disadvantages, I would say like security concern will something that comes to my head first when I talk about disadvantages in IoT. Okay, like data breaches. Okay, then there are privacy issues. Okay, related to maybe the collection and the use of personal data, right? There is a lot of personal data in either device involved. So also dependence on technology and potential of the system of failures that are more like dependence increases, right, on the technology. We are getting more dependent on that technology to do certain tasks. Then it could be another thing could be there could be higher in initial investment costs, also limited battery life definitely. So concerns about could be displacement due to automation, or limited regulation and legal framework for IoT, which can also lead to confusion and uncertainty. So that something like that could happen, and that could be a disadvantage. Okay, then of course limited standardization and interoperability among the devices. So also complexity and increased maintenance requirements. So such things are there. There are a lot of disadvantages also, but you just have to look at it that way. Okay, just change the perspective of looking at it. That's the basic thing. So it's 9:20. Let's stop, okay? So that you also get 10-minute cup break before Yash starts his lecture, okay? Thank you so much. Have a nice Sunday.